Okay. Hi everyone. So today we're going to talk about agentic AI. And by that I mean we are really entering a whole new paradigm in AI. And so we are moving from models that respond to some systems to the ones that are autonomous and the ones that are independent to make some decisions by themselves. So traditional machine learning, as we thought of so far, are just essentially some static predictions where we're just training some models and getting some output out of those trained models. So LLMs, which we talked about in the previous lectures, are generative intelligence. So they are generating some new knowledge based on they have been trained on. But agents in general, when you hear an agent, they most of the time have some goal directed to what they're doing, and so they're also autonomous in their by nature. So before we start, I'm going to introduce what's the content of this lecture. So we're going to start first by introducing what do we mean by agents in AI. What is the new paradigm of React? And here I mean by React reasoning plus acting, the tools and environments, and what are some agentic AI frameworks. We're going to focus on the small agent framework since it's mostly free for you, and you can also get a certification out of that at the end of the course. Okay, so let's just ask the first question is what's an agent? So as I mentioned before, an agent is a system, is a software that can reason and can act autonomously, right? So it has the independence of making some actions. And so when I say an agentic AI, it means an agent which uses typically an LLM, right? So the large language models such as ChatGPT or Claude provide a lot of tools for it in that can help him also achieve the goal of the agent. It is also a very much goal-driven behavior. Typically, agents have some set of goals which they need to achieve, and they can have access to a set of tools in addition to the LLM that can help them achieve those goals. So they are independent to make some decisions, but the whole principle is that they want to achieve a goal. So in this figure over here from the small agent course, you could see that, well, Alfred, which is an agent here, can reason and plan, right? So it can have a pipeline of thoughts. So here, in order to make a party, first he needs to make the coffee, how to make the coffee, he needs to run the coffee machine. And to do so, well, he has a set of toolbox. Well, he has a coffee machine, he has a blender, and he has also the access to the LLM through his laptop. And that's how Alfred can achieve the goal of organizing a party, starting from the coffee. Okay, so how does agent work? Is the question that we're going to answer here. So an agent can be broken into three main layers. So the cognitive layers is what is known as the large language model layer. So here in this first layer, it helps the planning, the reasoning, and the memory. Right, so which is actually the context window. A lot of people mention that or refer to the LLM as being the agent's brain, right? So it's the reasoning engine of the agent. The second agent is the tools, is the tool layer. And tools could either be under the form of APIs calls or code executions, like the case for code agent. It can also be a retrieval system, like a RAG agent here. So some functions that can be called are also examples of tools over here. So search and API calculator is a tool that an agent can have access to in this case. And finally, the environment. So the environment layer is a third layer. And what I mean is typically the environment is dynamic, right? So it is somehow observable, and it is also very much stochastic. What I mean by that is that So databases are taking effect or changing, or getting updates every day. Web services are and feedback is something which is given on an online fashion. So the feedback loop here is dynamic by nature. So this is the last layer is what forms the external world. So the external world, which is composed of data and system. And as an example of these three layers, as shown in the slide in green, the thought which can come from the agent's brain, which in this case could be, well, I need to find the latest weather in Paris. And how to do so in order to achieve this goal after having this thought, the agent might call some tools, right? So the tool here is the searching the web browser by saying, hey, what's the weather in Paris? Or in case you have a function that does so for you, you can call the function through your tool calling agent. And finally, the observation, which is from the external world, is that, well, it's 18 degrees Celsius and it's also cloudy, and that's the observation that you get from the environment, and that the tool helped us grasp in this case. Okay, so the next slide is about tools. We're going to talk about what do they mean and why do we need them. I think, but let's try to find what do they help us solve first. So a tool is typically a function. It's given to the LLM, and it should fulfill some kind of objective. So tools helps us solve three main core limitations of LLMs. The number one is that there is no real-time data, right? So LLMs are typically trained on historical data. They're not the most up to date systems necessarily. They're also weak in computations. In fact, they suffer from a problem such as hallucination. Right. So in the previous example, I told you about searching the weather in Paris. If you ask your LLM, it might hallucinate. It might tell you, well, based on the training data, usually we say that the weather is about 20 degrees Celsius. So let's just say that it's not necessarily the truth. So this is called a LLM hallucination. So they're kind of weak in computation. You might see that also in math. If you give them a very high end math, they might not do, let's say, the derivation in a proper way. They also don't have external actions. So the LLMs do not have independence or decision making process in the way they are built. So tools are how we can really empower the LLMs in reality. There are many categories of tools. You might have heard of retrieval tools such as RAG. There's also execution tools where essentially the code agent produces some Python or SQL code. And there's also actuation tools like APIs or robotic tools that can also be used. Um, so here, some example here that we have in the slide. So we have web search. It allows the agent to fetch up-to-date information from the internet. An image generation tool can create images based on some text description. And I think already these kind of tools have been added to the ChatGPT modern or latest versions here. Okay, so this is just an example of how can you define a tool in Hugging Face and in Hugging Face or using the small agent framework here. So a tool definition typically must have a number of elements. The first one is, of course, what's the name of your tool, and you can describe it in layman's language. In this case, what is the tool is intended to do, and why is that? Is because it helps the LLM understand why or it can help the agent understand why they can use this tool. And it's also in the function, the function, it has a function to call and some input and output arguments that we have over here. Uh, you can use a decorator, which is at tool in this case, in order to define the tool functions as follows. So the very first one over here is just template of the tool, and the second one is the definition of the tool over here. So using the add tool, you can define it such as a function call over here, which is calculator. And we know that the calculator tool has already been defined, and we already know by the description what it's supposed to do in this case. Okay, so the agent loop. The agent loop is kind of an iterative policy refinement process. If you think about it, an agent. Here the idea is that the agent do not solve problems in one pass, right? So they need to search through some solution in some space of time, right? So the agent typically have to think, act, then learn after the what's the output of their action, and then and observe before they think again over here. So the thinking or thinking process, also known as the reasoning, is where the agents analyze the problems and plans the next steps ahead. How can they achieve the goal? The execution or the action is when the agent performs that particular action, such as calling tools or some external systems here. And the observation, which is the feedback, which is provided by the environment, right? So here, the agent receives some kind of results based from their actions, and hopefully it can use that feedback to update its understanding and have better actions in the next time. So the agent loop is all about thinking, acting, acting and observing in a loop process. So how does agent work? And this is a step-by-step process over here. Agents typically rely on the React approach, and React simply means reasoning, which is thinking, with an action, right? So which is the act or the second part of the React word. So React is a prompting technique that encourages the model to think step by step, and it also allows you to do some actions like using tools between reasoning steps, right? So why does it work? Well, it's simply because it reduces the hallucination that are in LLMs. It enables us to use some tools as opposed of just using an LLM, which doesn't necessarily have all types of tools which are necessarily to achieve a given goal. And it also improves the multi-step reasoning, right? So React is it's kind of a chain of thought with with an external verification as well, because you get also an observation out of the actions that you're making, and or hopefully you're making better actions later on. So this is just how it works. The very first step here, you get a task, and then the LLM reasons about that tasks, and it calls on some set of tools which are available to the agent in this case. Based on the tools, it makes some action, right? The environment, so that action will result in some kind of output, and that's the fifth step that you get over here. Finally, the final step is that given result is passed down to the LLM, and the LLM again has a response out of that observation, and here after reasoning back again. Okay, so now let's zoom in each one of these steps that we have here: thoughts, actions, and observation. So let's just talk a little bit about thoughts in details over here. So there are multiple types of agents, right? In fact, there are two most important ones or popular ones. There is what we call the code agent. They are the most flexible, and they're also Turing complete. There is also tool calling agents. They are structured, safer, and most of the time these are the ones that are used in production because they are way better fit for industry kind of setting here. So the trade-off here between the two types of agents, code or tool calling agents, is the flexibility versus the control, right? So in this case here we are talking about the flexibility of code agent. They are quite easy here versus the tool call agents are giving you a little bit more control in this case. So the thoughts are some example of thoughts over here that an agent can have is about decision making, right? So a given user's budget constraint, I should recommend the mid-tier option versus the first tier or the high tier option maybe of a loan. It can also do some prioritization, right? So the security vulnerability should be addressed before adding new features to a given code, maybe or software that you're trying to maintain or develop over here. It can also have some problem-solving thoughts, such as in order to optimize this code, well, I should first profile it to identify what's the bottleneck of this code. So these are examples of thoughts that agent might be having during the React paradigm. Okay, an example of actions over here. So actions are some steps that the AI agent takes in order to interact with the environment. There are multiple types of agents that take action differently. So we talked about code agent and function calling agent mostly in the first slide. So a code agent typically writes code in Python language or high level language as a response. So that's the action that it takes. A function calling agent, on the other hand, it's a subcategory of a JSON agent, and it generates a message for each action. So this is on the left hand side, you could see a JSON agent in this case, where the action is specified in JSON format as the name name suggests. On the right hand side, the code agent, on the other hand, generates pieces of or code blocks, in this case in Python language, as the action after the thought. So the thought here is I should calculate the phone price in USD for each country, then find the most cost-effective country. And so the code here is a Python code which has a list of countries such as USA, Japan, Germany, and India, and it wrote a for loop across those countries that makes the exchange between the currencies here from to a USD from each country, each of those countries' currencies here. An action, again, so there might have multiple types of action based on the type of agent that we're talking about. A tool calling agent can use a tool usage as an action. So in that case, it makes some API calls, run calculations, and execution codes over here. It might also engage with other agents, and that the action here is the communication. For the case of a multi-agent setting, it might engage with users via chat or collaborate with other agents as well. Okay, observations. So the observation, as I said, this is the signal from the environment that an agent receives as a response of their actions. So in this particular phase, the agent collects the feedback, so essentially receives data or confirmation that its action was successful. It appends the results and based on that feedback, and it adapts the strategy by taking further actions or bettering the next action based on the results that it received from the first set of actions. Okay, so now that we understand actions, thoughts, and observations, which are the three essential steps for an agent to agentic AI work here. So we're going to talk a little bit more about what are the frameworks that are popular here for agentic AI. So some popular frameworks include smolagent, LangChain, AutoGen, and also there is also Crew AI. So frameworks, per se, you can think of as the abstract for the agent loop and the whole tool orchestration. They are kind of like the IDE of your agent in that case. So how can you write the way you write a code agent and define new tools is through those frameworks. So typically, smolagent is for lightweight purposes. LangChain has some more modularity in it, while AutoGen and Crew AI are more like team-based or multi-agent systems here. So we're going to focus in the remaining of this slide about the small agent framework over here. So small agents, as I mentioned earlier, it's more like a lightweight framework. It provides LLMs with the agent to interact with real words, such as searching or generating new images. It is ideal for cases where you want to experiment quickly without having to do some complex configuration. And as I mentioned before, you need a lightweight and minimal solution. So it also focuses mostly on tool calling in the code. So it highly simplifies the code execution because there is no need to parse JSON to build code that calls the tool. So the output can be executed directly for the case of a small agent framework here. Two types of agent, code agent versus tool calling agents are the ones that we're going to talk about for the context of small agent framework here. So a code agent here is one of the most popular type of agent in small agent. It is the one which writes code, the code that uses tools, right? So in this code snippet, you could see how can you define a code agent in small agent. So for small agent, you just import the code agent library and the DuckDuckGo search tools, and this is just another interface client model over here to run the agent. So the agent is defined as a code agent which uses a set of tools. So DuckDuckGo search tool is something which is already defined and available to you through the small agent framework over here. So you can run the code agent that you just defined by just saying agent.run search for the best music recommendation for a party. So when you run this example, the trace of your agents will output what's the result of your of the query that we have over here. So what's really happening here is that the LLM generates the code is executed, and then the output is fed back to the agent over here. Okay, so I think the next thing that we're going to talk about is a demo of the way the code agent works in using the small agent course over here. So let me just stop sharing and reshare my screen or share the demo over here. So this is just an example of example notebook which shows you how a code agent can be defined and not only answer in text, but instead it can write and execute Python code to solve a given task. So in this example, Alfred, which I defined earlier, is preparing a party at Wayne's mansion. And the agent needs some help with music, menus, timing, catering, and also party themes. So the notebook is from the Hugging Face Agent course, as you might see from the link over here. The very first thing you want to do is, of course, to install the small agent, the small agent library. And the reason is this package gives us some building blocks for creating agents that can use the tools. And so, of course, we need to log in through Hugging Face, either through the guest or through your account, which you might already have created through your Hugging Face hub over here. We already talked about this. This is how we create an agent. So first we run the code agent. We call the code agent class over here, which we initiate with a web search tool, which gives the agent access to web search. So the inference client model here, what it does is it connects the agent to a Hugging Face hosted model. And of course, when we call agent.run, the agent receives the tasks and it decides that it needs a web search. So in order to do so, what the agent does is that it writes some code in Python, right? So the agent in the back door is writing some code over here in order to answer the call by writing music recommendation equals to web search over here. Web search query is the best party music for Grant mentioned over here. And finally, it prints out what's the what's the answer over here. So this is the kind of this step over here is the kind of code that the agent is generating in the back doors after running the code agent over here. Code agents are the ones that can generate high level language code here, such as in Python, in order to achieve the task. And the task here is to help organize the party in this case. Okay, so the second thing that you could do over here is you can create a custom tool with the tool decorator, which we already talked about. This is an example of how can you write a tool. So this tool here is just a function which you define that which allows us to suggest the menu based on the occasion, right? So based on the occasion of the party, it can suggest what type of menu. If it's a casual occasion, then pizza, snacks, and drinks are the ones to be suggested. Otherwise, if it's a superhero party, then the buffet with a high energy and healthy food is an example of suggestion, and that's what the function is going to return over here. So the code agent here can be defined by taking a custom-made tool that we just defined ourselves using the tool decorator, the tool decorator over here. So suggest menu is the name of your tool that you pass down to the tool set of the code agent. So next time the agent is run, you run your agent by preparing the formal menu for the party. The agent can have access to the suggest menu tool that we have over here. Okay, so yeah, in fact, the agent can also receive not only one single tool at a time. You can also play by adding, when defining your code agent, can have multiple tools. So web search as well as visit web search, web page tool, which is also part of the small agent library. The suggest menu tool and the catering service tool, which are the tools that you just defined using the tool decorator, the tool decorator in the previous code over here. And verbosity level is essentially just letting you know how much of level of details you want you want your trace code to be detailed in this case. So if you want a more trace, like in this case, you can see exactly what's going on at the level of the execution and iterations of the code agent as it moves from thoughts to actions throughout the code agent React loop over here. Okay, and finally, I think another thing we might I need to bring here is the fact that you, in addition to writing tool using the decorator, the decorator tool over here, you can also create tools using a class based tool over here. So here you can create a class superhero party team tool, and that's a tool over here that you can define over here. So instead of just having the add tool previous to your tool definition over here, you can define it as a class over here. You can also load an agent from Hugging Face from the Hugging Face hub, which you already have here. But before that, you should have an account with Hugging Face to be able to do these kinds of this kind of executions over here. So Hugging Face hub has a lot of agents which have been contributed from the community. You can load them directly. For example, here I think the Alfred agent is already available to load from the hub. So if you just go to Alfred agent, right? Yeah. So here, so if the code that I'm highlighting here, agents.from hub, and then you can just say, hey, from where exactly you want to load the agent here, and the fact that you're trusting that remote code to be loaded for you. So many tools have already been contributed to the Hugging Face in Hugging Face that you can also directly load instead of just re-implementing everything by yourself. Okay, so I highly encourage you to have a look at this notebook and also run it for yourself and see how a agent for party organization and music recommendation works in practice here. Okay, so let me just go back to my slide for a second over here. So the second type of agent, so the code agent is the one that I just talked about so far. A tool calling agent is the second type of agent that we talked about. And now a tool calling agent, as opposed to code agents which generate code, they use some built-in calling capabilities of LLM's provider. They just generate some tool calls as the JSON structures. So this is just a code snippet of how can you define a tool calling agent. You can also still pass down some tools such as a web search tool to your calling agent. But in this case, if you just go back to the trace of your tool calling agent, you'll find that, well, it's just some JSON structured messages that you're getting and not a high level Python code such as the code agent here. So tools are already we already talked about tools and how they are useful. We also talked about how can you create your own tools or even load tools from the hub or from Hugging Face hub over here. So the small agent comes with a set of pre-built tools that can be directly used by your agents. Either it is a code agent or a tool calling agent here. An example of those default tools are Python interpreter tool, find and answer tool, Google search tool, DuckDuckGo search tool, visit web page tool as well. So one of the most powerful features of Small Agent is its ability to share custom tools on the hub. Already talked about this. Sometimes you don't really need to re-implement everything from scratch using the tool decorator or the tool class, but instead of that, you can just easily look whether those tools already exist in some kind in the hub and just load them very easily here. You can also contribute to the community, which is an example of this is on the left hand side quadrants that I am highlighting here. So you can push your new tool to the hub using your own account and your token, which is your secret token given to you in order to access your Hugging Face account over here. That way, you can help others make or take advantage of your already implemented tools when they build their code agent or tool calling agent in the future. Okay, so this is just an example of another a demo of another tool. I invite you to have a look at how this notebook works for both the tool as well as the tool calling agent and run them by yourself. Other than this, if you have any questions, please let me know by email and have a lot of fun with the handout for this portion of this course. Thank you very much.